So the next question, we have been given that g be a function defined by g of x is equal to e raised to the power of 2x positive 1 for all real x, then limit x tending to 0 g of x negative g of e over x has to be found. Now these are the choices given. You can pause the video and work the question out and see if you are able to zero in the right choice. Okay, so I hope you all have got the solution. So let's move on. Now what we are given that g of x is equal to e raised to the power of 2x positive 1, right? Now if I were to utilize the definition of limits, we can easily identify that this is nothing but the derivative of a function. So we can go in that direction, or what we can do is we can actually go in the direction of applying limits. So let's go in the direction of applying the limits. Now what I'm going to do is I'm going to apply limits. Applying limits, we get. So where are you supposed to apply the limits? You are supposed to apply the limits of x tending to 0 to g of x, right? This is how it looks, negative g of e divided by x. So as x tending to 0, you will have to foremost find out each of these values, right? So that's exactly what I'm going to be doing. Now g of x is e raised to the power of 2x positive 1. So g of x is going to be equal to, in place of x we substitute g of x. So this is going to be e raised to the power of 2 times of g of x positive 1. Okay. Now what is actually g of x? So it's going to be equal to e raised to the power of 2 times of our g of x is going to be e raised to the power of 2x positive 1, and you have a positive 1 there. Now we have to apply the limits. So as x is moving to 0, tending towards 0, you substitute the value of 0 here, right? You get 0 positive 1, that's going to be e. So this is going to be equal to e raised to the power of 2 times e, and you have a positive 1. So this is the value for g of x as x is tending towards 0. Okay, fair enough. Now we already know g of x is e raised to the power of 2x positive 1. Now for x is equal to e, g of e is given here, right? So we need to find the value of g of e. So what is g of e? G of e is nothing but e raised to the power of 2 times e positive 1. Now hence, if we were to substitute the values that we have got, what are we getting here? For this quantity, we have it over here, right? So this is going to be e raised to the power of 2e positive 1 followed by negative sign, and e raised to the power of 2e positive 1 divided by x is tending towards 0. So you're going to have a 0 here. So the numerator is going to give me 0, denominator is going to give me 0. So this is 0 by 0 form. So once we get 0 by 0 form, we have to apply L'Hopital rule. So what exactly is L'Hopital rule? L'Hopital rule, I'm going to use this side of the space. So applying L'Hopital rule, we get. So you differentiate the numerator divided by differentiation of the denominator, then you apply the limits. So this is going to be equal to g dash of g of x, right? If you differentiate this, you're going to get 0 divided by 1, differentiation of the quantity in the denominator, right? So you have to find out the value of this. So let me go up here. So what is g of x? G of x is given as e raised to the power of 2x positive 1. This is my g of x. Now g of x, this is going to be equal to e raised to the power of 2 times of g of x positive 1, right? Now g dash of g of x is going to be equal to, when you differentiate this, this is going to be e raised to the power of 2 of g of x positive 1 multiplied with differentiation of this. This is going to be 2 times g dash of x. Differentiation of 1 is going to give me 0. So you have 2 times e raised to the power of 2 times of g of x positive 1 multiplied with g dash of x. Okay, this is what we have. Now since I mentioned to you, we already have g of x. G of x is e raised to the power of 2x positive 1. Now what is g dash of x? G dash of x is e raised to the power of 2x positive 1. Differentiation of 2x is going to give me 2. So this is 2 times e raised to the power of 2x positive 1. So we have to take everything and substitute here. So I'm going to write it as 2. So therefore 2 can be rewritten as 2 times of e raised to the power of 2 times of my g of x. My g of x is e raised to the power of 2x positive 1. Is it not? So this is my g of x followed by a positive 1 there. Okay, multiplied with g dash of x. So g dash of x is what? This is going to be 2 times e raised to the power of 2x positive 1. Yes, it is going to be g dash of g of x. Now we have to apply the limits. Applying limits. What is the limit? X is tending towards 0. 2 into 2 is what? 4. So you have e raised to the power of 2 times, see there's a formula, a raised to the power of n times a raised to the power of m is equal to a raised to the power of n positive m. So we have 2 times e raised to the power of 2x positive 1 multiplied with e raised to the power of 2x positive 1. So I can rewrite this as 4 times e raised to the power of 2 times of e raised to the power of 2x positive 1. Both of them are exponents, right? Positive 1, and then you have to add this also, 2x positive 1. You need to add that. Okay, so this is rewritten as 4 times e raised to the power of 2 times e raised to the power of 2x positive 1, and then 1 added with 1, that's going to be 2, and then you have a 2x. Okay, fair enough so far. Now as x is tending towards 0, 2x will also tend to 0, so this one goes up. So you are left with 4 times e raised to the power of 2 times of x is equal to 2x is going to be 0. So this is going to be e, right? Positive, there's a 2 there. Okay, so this is what we have got. Now the question is, we will have to go and check whether 4 times e raised to the power of 2e positive 2 is there. See, I can outrightly I can see that 4 times e raised to the power of 2 times e positive 2. Is it not?